Lab Coat Lizzie, run!
Dr. Science, I'm on it! Wow, this is really getting tiring. I don't know how much longer of this I can take.
I know. This is insane. Dr. Mad has gone insane. Threatening to remove gravity and everything. It's just weird. It's crazy.
That was the scariest part. A world without gravity is not good.
Not at all.
We won't have any force to keep us on the ground anymore. We're all gonna be floating, and there's going to be no balance in the world.
Well, do you think he really meant what he said? I mean, we know he was capable of removing things like living things, but gravity? That's insane. That's too much. It's too hard for him.
Dr. Science, look.
Oh no. This is bad.
This is really bad.
Oh no. Not again. Let's go back to the lab right now.
Sounds good. Okay, it's time we put back on our science hats. We stopped Dr. Mad once before, and I know we can do it again.
With the help of Super Science Kids First. Welcome aboard, everyone.
Welcome to Super Science.
Week 3.
Physics fun.
Today we're changing gears and talking about another type of science. A different type of science. Physics. It has to do with collisions, gravity, falling objects, and anything you can think of that has to do with interactions between objects.
Dr. Science, I have yet another question.
Yes, Lab Coat Lizzie?
So, you mentioned the word physics, but what is physics?
That's a great question, Lab Coat Lizzie. Physics is a particular area of science that deals with objects and their interactions with each other. For example, two objects like a toy car and a toy truck colliding with each other. Using physics, we can determine when they collide, how fast they're going to be colliding, and even how powerful the collision will be. Another thing we can look at is a falling object. Have you ever wondered why objects fall?
Yeah, but I never really understood why. Why does an object fall?
That's a great question, Lab Coat Lizzie. Let's find out.
That brings us to
Lab time! Here, and we're back with another experiment. This one's also another really quick one. In this one, we have two balls of different sizes and different weights. This is the larger ball, and it's heavier, and this is the smaller ball, and it's lighter. Which one do you guys think will hit the ground first when I drop them from the same height? Pause the video and think about it. Do you think the heavier one will hit the ground first? The lighter one? Let's find out. Wow! They hit the ground at the exact same time, but they look completely different.
Well, so now we have two balls of significant difference. The tennis ball was a little too close in size to the other ball we used. So now we're going to try using a really big ball and a tennis ball. What do you think is going to happen now? Do you think this ball is going to hit the ground first or this ball? Well, let's take a look. Once again, they hit the ground at the same exact time. So now we're going to try with the really, really small one and the big one. You guys think the same thing is gonna happen again? And once again, they hit the ground at the same time. So, why do you think that is?
The object experiences a force called gravity. Gravity is an invisible force between two objects. In this case, the objects are the balls and the Earth. Earth is very, very large, and because it's so big, it has a strong gravitational pull. The larger an object is, the greater their gravitational pull is. The closer objects are to each other, the stronger their gravitational pull are on each other. Gravity acts the exact same way on every single object on or near the Earth's surface. That even includes us. That's why the balls fell at the exact same time. Do you think the balls are pulling the Earth?
I don't think so. I don't know. I don't think so.
Actually, the balls are pulling on the Earth with the same force the Earth is pulling on the balls. It's just that the balls are so small compared to the Earth that their pull doesn't have any effect on the Earth. Let's talk more about this kind of phenomenon after our next experiment. Let's go. Science here. ready to show you guys another fun experiment. Here we have a bucket full of water. Well, half full. Anyways, I'm gonna try to basically spin it with my arm. What do you think is gonna happen to the water when the bucket is at the top? Pause the video and think about it. Did you think that the water would fall out and, go on top of me? Let's see. Wow, the water is completely in the bucket. Nothing spilled.
Wow, that was so cool. I thought the water was gonna come falling down on you. Can I try?
Yes, Lab Coat Lizzie, you can.
Okay. All the water fell out.
No. You did it all wrong. Lab Coat Lizzie, try again, but swing faster.
Okay. All right, let's try it this time.
Perfect!
Wow, no water fell out.
So, we just did a second experiment, and this one dealt with Newton's first law. Newton actually has 3 laws, but we'll only talk about the first and third today. Newton's first law states that an object in motion stays in motion, and an object at rest stays at rest unless an outside force acts on it. Let's break this down. A force is any interaction that causes an object to move. Basically, when we moved the bucket of water really fast, the water didn't have time to fall out when the bucket was at the top. Instead, the bucket continued to move in a circular path because my arm was moving really quickly. The final law, or the third law for Newton's laws, is that for every action, there is an equal and opposite reaction. In the case of the earth and the balls, earth and balls exerted the same force on one another. It's just that the earth is much, much larger than the balls, so the balls didn't have any effect on the earth. It's sort of like trying to move a small kid versus trying to move an adult. You can easily move a small kid, but if you try to push with the same force on an adult, they might not move because they are larger.
Wow, I learned so much today, and I hope you guys did as well. I feel like I'm seeing the world in a whole new way. Now let's talk about this week's Scientist of the Week. This week, we're going to be talking about Stephen Hawking, who was one of the most incredible scientists, physicists, and human beings ever to have lived. Hawking was a mathematics professor at the University of Cambridge in England, and he wrote a novel called A Brief History of Time, which became an international bestseller. In 1963, Hawking contracted motor neuron disease, meaning that he couldn't move parts of his body, since neurons tell our brains to move our body parts. He was given only 2 years to live, but a miracle happened. He continued to live despite his condition and went on to Cambridge to become a brilliant researcher. Hawking could not talk with his mouth, walk with his feet, or do the normal everyday things that we get to do today. Yet, despite these setbacks, he went on to become a brilliant physicist who made numerous discoveries on black holes.
Wow, Stephen Hawking is such an inspirational person. I could never imagine not being able to walk or talk or even not being able to get out of bed every morning.
And not walking and doing all of these things like moving my hand, that's crazy to think about. I hope one day we can be half the scientist he is. And I think I know just the right first step to get us there. I think we need to take a trip to the Activity Arcade. Hi kids! So this week we have a really fun, exciting, and interactive activity for you guys, and it's called a Rube Goldberg machine, which you guys are going to be making. So some of you guys may already know what that is, but for those of you guys that don't, a Rube Goldberg machine is when you perform a very simple task in an overly complicated way. And here at the Super Scientist Lab, we have a lot of scientists that we work with who made their very own Rube Goldbergs. So we want to show them to you here. You can find materials and objects from all over your house. It can be anything from books to strings to cups to dominoes. You can use any tiny object or any big object from your house. And all you have to do is choose a simple task that you want to accomplish. This could be turning off the light, closing the door, closing a book, pressing the space bar on your computer. The options are limitless. So we would love to see your submissions, and it's going to be an amazing time for you.
Take 400.
Ready?
Go.
Oh no.
So the goal is that we're going to call the phone so that it starts to vibrate and move, and then it's going to move this ball, which is going to go down this ramp, and it's going to hit these books and then hit some more things, and then there's going to be a tennis ball up here, and then it's going to go down there, and the goal is that it's going to hit the stapler, and the stapler is going to staple the paper. Okay, so we updated the system so that the ball is gonna funnel down so that it can lead right to the books, which is gonna fall onto the staple and put a lot of weight on it, so it's actually gonna staple. Okay, wait, let's see it, let's see. Hold on. Yeah! Well, that was a crazy day.
We learned so much. More importantly, we had fun. Physics fun.
And guess what? It looks like gravity is gonna be around for a while. I don't think we have to worry much anymore.
Yeah, but I still feel off. I don't know. The world seems off.
I know, we may be on the ground and everything right now, but something isn't right.
Oh gosh, I hope Dr. Matt isn't back. He can't be back again. Hold on, I just got a call. Let me pick it up real quick. Hello, Dr. Science speaking. How may I help you? You won't believe what just happened. You already know who it is. This time, he threatened to remove sunlight from the Earth.
That means we're all going to die. We have to get to his lair to stop him.
Should we even go? It could be a trap.
Well, I guess we'll just have to go and see.